Hello everyone and welcome to another video, and as you can see I've done it. So this is the GTX 680 I was talking about, the test subject for my first attempt at e-powering a card using copper plates, and it's working. So the card still has the memory problem. You can see my memory clock's 500 megahertz. If I put it to like 550 the card crashes. And also I've done some things to the BIOS basically I was testing which memory channel was bad, so I just went into the BIOS, made some custom BIOSes and started disabling one memory channel after the other. Sadly, turned out that not a single memory channel is faulty. All of them have problems. Like, I think the C channel clocks a bit higher. That one's good to like 650 megahertz, but all the others crash at like 550. Both far below the 1500 stock speed. So yeah, so the fault doesn't seem to be in a memory chip, but rather in like the memory controller, or like one theory I have is like behind the core there's a couple resistors that set things like termination resistances for your memory controller. One of those might be broken. I didn't see anything visually, but resistors sometimes break without looking bad. The problem is just I have no idea how to diagnose that. I might have a 680 board view actually, but I don't know if that says the resistor values you should have. Anyway, I don't think it's really worth testing though, because like the one thing I wanted from the card is make a proper performing e-power, and the core portion of the card works fine. You can see it runs GPU Pi 1 minute 3 seconds. That's actually faster than some subs on HW board at a higher clock. Like this one is like 1084, and I think I saw some like 1150 subs that were like 1 minute 5 seconds. So even with like cut down memory and super low, slow memory, this one still does GPU Pi just fine. So I guess it's good for that, and I guess it's getting sub-zeroed in GPU Pi, because that's like the one thing the card can do, because like at this memory speed it's not running anything else in any way that matters. But yeah, so for the e-power part, there's a couple things that went really well and a couple things that went not well. So the things that went really well is that I had a very easy time attaching this e-power. It was a lot faster and I think a lot less hassle than doing it with cables, because it's just two copper plates, a ground plate, V-core plate, and yeah, technically the memory is e-power too, but since this card is such big memory problems, I think I'm just going to leave it at this one cable and just like keep pumping 1.7 volts into it. Then it works. And before you say that this is what causes my problems, no, the card did that before. Like, it used to have a different e-power on it that had proper memory connections, and it still had issues then. So no, that's not why the memory clock is weird. So yeah, I think copper plates, like, pretty easy to solder, especially if you have a soldering iron like I have. So let's go to my work area that I still haven't cleaned. So this is the soldering iron I use. This is a 150 watt iron that I literally picked up today in the hardware store next door, because my old 150 watt iron, this one, it died. I don't know what happened. I turned it off one day when it worked. I turned it off on the next day and it wouldn't get hot anymore. And I also checked with the kilowatt meter. It does not draw any power anymore. So I guess the heating element inside that thing just completely died. So yeah, I had to get a new 150 watt iron. And as it turns out, this one wasn't just cheaper, this one's also a lot stronger. So both are technically 150 watt, but this one heats up within like 3 minutes. The other one takes 10. And this one is a lot stronger because this thing actually started destroying my V-core power plane. So, oops. So you can see this. That used to be one more or less complete strip of V-core power plane. That now has a big hole in it. That's also why this extra cable is here, because that's supposed to kind of like replace the V-core power plane I lost. Yeah, so when I started soldering on the V-core plate, it used to be a little bit more to the left originally. It it just started disintegrating the V-core power plate in that area. So I guess that's how strong the iron is. To be fair though, this PCB has been through a lot. It had 3 different E-powers. Actually, I remounted this thing 3 times. So technically it has like 5 E-powers, but this is the 3rd time where it's like in a... Well, it was working before with just 1 connection, but anyway, like, this is the 3rd E-power that I completed, more or less. So this V-core layer probably is a bit more abused than what you would have on a normal card, but it doesn't change that I kind of destroyed the V-core power plate on accident. That's one of the things that didn't go so well. So, other thing that didn't go so well is the V-core plate. So you can see the ground plate behind here. That one looks really nice. It's just 2 simple 45-degree bends. I did go through with the entire plan of using the switch nodes. You can see I put like... so I pulled the insulation off of 2 wires and put those across all the switch nodes and the ground layer, so those are now connected. And you can also see I put the plate down in such a way that it also uses that other like small ground layer in between. So the ground we have here should be really good. I haven't made any behind core voltage measurements yet because my mounting currently doesn't allow for that. But yeah, so the ground plate looks really nice. The V-core plate, is less good. So, not just destroyed power plane, I also had to put this extra piece in here because you can see it's kinda bent. So it didn't make contact with the E-power in this bit. So I put a little bit of extra copper there to have contact. And then it also is just a bit bigger than it has to be. So it wouldn't need to have this 90-degree bend in it. It could be just like a straight one like the ground one. But I made this one a little bit too big, and I really didn't want to Dremel it, like cut it again. Because my Dremel is alright, it's just not the strongest ever. So cutting these copper plates actually takes some time and is a bit tedious. So I chose to just like bend it a little bit, because it's probably still fine. It just doesn't look that great. Also, thing is, my flux is absolutely disgusting. I have some super cheap flux. I need to get some proper flux because this brown residue that it leaves everywhere just looks absolutely awful, and I would like to not have that anymore. Yeah. And one last thing that you're gonna notice is this red bodge wire, because so I made a video about a GTX 760 192-bit card a while ago, about repairing that card. And that card had a dead PEX rail, and the IC itself was dead, like the little 8-pin IC that creates that rail was dead, and I ended up replacing that one. And the chip that I replaced the dead one with on the 760 is the chip I pulled from this card. So this one only, so the 680s have actually 2 PEX rails. So one is here, this one, and then the other one sits here, where there's just an empty pad now. So I don't know why 680s do this. I'm not aware of any other card that does this. But basically it has 2 PEX rails. Like they are not connected together. They're independent rails, but they sit at basically the exact same voltage, and I think they do the exact same thing. More or less. Like obviously they're not connected together, so they do power different things. But on every other card, as far as I'm aware, that would just be one rail. So anyway, you can probably guess what I did now. I took the output from one rail and jumped to the output of the missing rail. So now we have our 2 working, our PEX voltage in both the places we needed, without having to get another little converter. So that's what this bodge wire is for, because without that we don't get detected or don't get display out. And that's that. And yeah, that's pretty much how it is. I am gonna run a bit of GPU Pi with this on the water cooler, and then probably tomorrow, if I have time, I'll take it sub-zero. You can see I already insulated the motherboard. So I'll be able to take it sub-zero. I might live stream that, depending on how I feel and how much time I have. Technically, I have a day off tomorrow, but I need to bring a bunch of packages to the post office that I need to send out to people. and I also need to do some uni homework, so I'll have to see how much time I have. But if I end up having enough time, then I might decide to live stream this or maybe record it if it's interesting enough. Because, yeah, I'm gonna do some Sub-Zero GPU Pi on this. And yeah, that's basically it. Because I just want to see like how good is the core voltage on this. Yeah, and I think that would be it for the video. So if you want to know more about the theory behind this ePower, I made a video already where I go over why I want to do the thing with like using the switch nodes as ground, and why I want to use copper plates and all that kind of stuff. Like why you want to do that, I went over that in the other video, so go watch that if you want to know more about this. Yeah. So I guess thank you all for watching, hope you enjoyed, and until next time, goodbye.